Example 6. Find the points on the curve y equals x to the fourth minus 6x squared plus 4 where the tangent line is horizontal. Where what we need to do is the horizontal tangents occur where the derivative is 0. So that's the thing that we need to focus on first here, is where the derivative is 0. So what we're going to do is we're going to find the derivative of this function. So recall that y and the derivative of y is y prime, which could also be written as dy over dx. So let's find the derivative of each term of this function. So we have d, or the derivative with respect to x, of x to the fourth minus the constant 6 times the derivative with respect to x of x squared plus the derivative with respect to x of the constant 4. So here we get the derivative with respect to x of x to the fourth becomes 4x cubed minus 6 times the derivative of x squared, which is 2x, and that becomes the derivative of the constant, which is 0. So then we end up with 4x cubed minus 12x, and that represents dy over dx. Okay, so now what we want to do is we want to find the values of the derivative where it has the horizontal tangents. So that means whenever we want to do that, we're going to let dy over dx equal 0, and then we're going to factor our derivative function, which is 4x cubed minus 12x, and we're going to set that equal to 0. So what can we do? We can factor out a 4x, and then what's left is x squared minus 3, and that's equal to 0. So setting them both to equal to 0, we have 4x, which is equal to 0, or x squared minus 3 is equal to 0. So we know x is going to equal 0. Or if we solve for x here, x squared is equal to positive 3. We take the square root of both sides. We get x, which is equal to plus or minus the square root of 3. And so therefore, this tells us that we have the following. That means that we have horizontal tangents when x is equal to 0, square root of 3, and negative square root of 3. Okay, so if we want to be able to then find out what those corresponding points are, if we take a look at our original function, which is y, which is equal to x to the fourth minus 6x squared plus 4. Okay, so when we let x equal 0, if we plug in 0, we get 0 to the fourth minus 6 times 0 squared plus 4. That gives us 4. So the corresponding point there is 0 and then 4. Okay, and then if we let x equal the square root of 3, then this is the square root of 3 to the fourth power minus 6 times the square root of 3 to the second power plus 4. You can either plug that into your calculator. So therefore, that's going to equal negative 5. So we have the square root of 3 and then negative 5. And then if we plug in negative square root of 3, then we have negative square root of 3 to the fourth power minus 6 times the negative square root of 3 to the second power plus 4 is going to give us the same result. So therefore our third point is negative square root of 3 and then negative 5. Okay, now what we want to do is let's graph the original function on Desmos. So let's go ahead and put in our function. So we have x to the fourth minus 6x squared plus 4. So let's take a look at that here. So let's take a look at these points. So we can see here that this represents the horizontal tangent here. And the square root of 3, negative 5 is the horizontal tangent there. And then negative square root of 3, negative 5 is the horizontal tangent there. So we can then graph the derivative to see what that looks like. So let's go ahead and graph the derivative. Okay, so we have 4x cubed minus 12x. And you can see there are your x values, which are negative square root of 3, 0, 0, 0, and square root of 3, 0.